Good afternoon, everybody. We got lesson 31 coming. Today is actually June 4th, so this lesson is actually not due till June 5th. So you might be opening it on June 5th, and that's fine. June 4th, special day, got balloons in the background. We got some birthdays today, closely related to me. My dad, his birthday today, and Copper. Today is Copper's birthday. And hopefully he doesn't escape on his birthday or do anything crazy. But anyways, just want to give some shout outs to the birthdays. And if any of you are having a birthday, happy birthday to you too. All right, so today I'm going to talk to you about the power rule of logarithms and show you how we use that to solve exponential equations. That's the plan. We're actually on the home stretch here. I think June 12th is the last day of instruction. I'm planning to get a quiz together and post that on Monday. Actually, I'll probably post it before Monday, and it'll be due Monday. So this lesson that I'm doing right now will be due Friday, June 6th, or June 5th, excuse me. And then the quiz will be due on Monday. Got to get more grades in my grade book. So we're on the home stretch of this disastrous thing we call distance learning. Can't wait to get back to school. So let me get resituated here and start talking to you about the power rule. All right, so we're going to talk about the power rule. Today in the background, we're going to see a bunch of different foods, some of my favorites. I want to apologize to anybody that's vegetarian or vegan. I like to eat, lots of meats, and I appreciate it if you're vegan and vegetarian. These are just my favorite foods, so don't take any offense to it. Why are you laughing? So, power rule of logarithms. The power rule of logarithms says that if I take the log of some number raised to some power, so I'm going to call it just b, I guess. What the power rule tells us is that I can take this exponent b right here and move it to the front of the log and change this to b times the log of x. Now that's a bunch of letters there, but I'll show it to you with numbers here in just a second. So there is the power rule of logs, though. It tells us that this exponent right here can come to the front of our logarithm. So let me show you with numbers. So if I have log of 3 to the 4th power. Now this is a base 10 log. We talked about those in the last lesson, the common logs. I'm using a common log just so I can show you how this works on the calculator. If I apply the power rule to this, it tells me this 4 right here can come to the front of the log, and this can become 4 times the log of 3. So let's confirm that on the calculator real quick. So let's do the log of 3 raised to the 4th power, and we get that answer right there, the log of 3 to the 4th. Now, if I use the power rule and bring this 4 to the front, like I've done here, and do 4 times the log of 3, I should get the same result. So 4 times the log of 3, you can see I'm getting the same result. So that's just verifying that the power rule works. All right, it is a valid rule that applies to logarithms, and we use it a lot, and I'm going to show you where we use it right now. All right, so here's our first example of how the power rule works. Got my other favorite food behind me, steak. I'm a big steak person. I love steak. Filet mignon, so good. Why are you laughing? Anyways, so if I have 3 to the x equals 27, which we learned to solve using like bases in previous lessons. So what I can do if I use like bases, let me just do that real quick over to the side. I can change the 27 to 3 to the 3rd, and if my bases are the same, that means that x must equal 3. That's how you do it with like bases. I'm going to do it with logarithms now. I'm going to use a common log to help us solve this. Because one of the things we talked about when we did this lesson was what happens if you can't get these bases the same. And then the next example, I'm going to show you an example of one of those. So if I want to solve this using logarithms, what I'm going to do is I'm going to common log both sides. And remember, common log means a log whose base is 10. You don't need to put the 10 in there if you don't want to. But whatever you do to one side of an equation, you must do to the other, so I've logged both sides. What this allows me to do is use that power rule and bring this x, which is an exponent, to the front of that log right there. So I now have x times the log of 3 equals the log of 27. And if I want to solve that, to get x by itself, I divide both sides by the log of 3. These will cancel out, and the answer is going to be whatever the log of 27 divided by the log of 3 is on my calculator. So if you take your calculator, and want to make sure you're careful with this, I'd probably use the fraction button. That way you don't have to worry about too many sets of parentheses. So remember alpha f1 or alpha y equals, choose number 1, that puts your fraction in. On the top, I'm going to put in the log of 27. On the bottom, I'm going to put in the log of 3. Hit enter, and I get an answer of 3, which is the same answer we got doing it using common bases. So 3 is our answer, and there's how you solve it with logarithms. So now let me show you one where I can't get these bases the same and I have to use a logarithm. All right, next example, I'm back to chicken wings again. Chicken wings, we've had this discussion in class. Who has the best chicken wings in the area? If you want to email me and remind me who you think has the best. We've voted on this a couple of times. We got Elbow Room, we got Bernie Murray's, we got Picnic Pizza, we have Harry's in Elmira Heights. They're good. I gotta be honest with you, Buffalo Wild Wings, not a fan. For a place that's called Buffalo Wild Wings, I think they would have better chicken wings, but just my opinion. So let me solve this one for you real quick. Here's an example of an equation that I can't get the bases the same. I have a 3 on the left and a 15.6 on the right. So I have to use logarithms here to make this work. So what I'm going to do is, just like the last problem, is I'm going to common log both sides. And remember, a common log is a log whose base is 10. We use that because we have the log button on our calculator. The x can move to the front because of the power rule. So I have x log 3 equals log 15.6. Divide both sides by log 3. That's going to get those to go away, reduce out. So my answer is going to be whatever log 15.6 divided by log 3 is. And that's calculator work. Use the fraction button on the calculator. I'm going to redo that again here. So we got alpha f1 or y equals. That'll get you your fraction. On the top, we've got the log of 15.6. On the bottom, we've got the log of 3. So it looks like that. And I'm going to hit enter. And this one's not going to come out as nice as the previous one. So when you have decimals, there's going to be rounding directions. I believe on your homework it says to the nearest tenth, which would be 1 decimal place. So to be consistent with that, I'm going to do that as well. And you can see that it's 2.500, etc., etc. So we're going to call it 2.5. Now, if you go to check your answer and you plug 2.5 back in for x, and you take 3 and you raise it to the 2.5, you're not going to get exactly 15.6 because of rounding. All right, so just keep that in mind when you're checking yourself. So watch, 3 raised to the 2.5 is not exactly 15.6. It's close, but it's not exact. And that's going to be because we rounded this answer a little bit and it's not as accurate. So that's how you use the power rule to help you solve equations whose bases can't be made the same. I don't need to do any more examples because if I did another one, it would look exactly like that. Well, hello, Copper. The birthday boy's here. Let's see him. It's Copper's birthday. He's pretty excited. Are you excited about your birthday? I don't think he is. All right. Homework time.